In this video we're going to look at completing the square. Now, a couple of things about this. We need to be able to express a quadratic with a unitary x squared coefficient in completed square form. Now when we use the word form, we basically mean how does this thing, or expression, how does it appear? If we start off with this quadratic with unitary x squared coefficient, all that means is something like x squared plus 4x plus 2. Unitary x squared just means 1x squared, so we wouldn't ever have like 2x squared or 3x squared here at National 5 level. So the other thing we need to do is we need to understand what this form here looks like. Now, it looks fairly complicated there, but basically all it's saying is I've got a bracket with an x plus or minus a number, all squared, plus or minus a number. So to give an example of this, you might have like x minus 3 all squared plus 2. And that fits in with this form. In other words, it has this appearance of x take away a number, all squared, plus another number. And these can be plus or minus in any of these two spaces. Before we look at how to change something from this form into this form, we need to maybe remind ourselves about how we'd actually square a bracket and what a square looks like. So all of the brackets on this page, they're all squares. They've all got brackets and they're all being squared like that. Now remember, when we square a bracket, what's actually happening is the bracket is multiplying itself. So that x plus 3 is multiplying itself. In other words, another x plus 3. When I come to square out that bracket, then I'll multiply out that bracket, I get an x times x for x squared. I get an x times 3, positive 3x. And because the brackets are same, I also get a positive 3 times x, which gives me another positive 3x. And then a 3 times 3, or 3 squared, which is plus 9. When I come to simplify that, I end up with x squared plus 6x plus 9. Now what's important here to note is that the terms here in the middle, because we're squaring the bracket, because this positive 3 is in both brackets, then I'm going to get this positive 3x, which means I'm going to get this number here, positive 6x. In other words, the number that I have here, positive 3, will give me positive 3x, which will give me double that, obviously, because these will always be the same, plus 6x. The other thing that's important to note is this term at the end, this positive 9, comes from actually just squaring the number in this position here. So that 3 times 3 will obviously square to give me that 9. We'll do the same with the other one over here, just very quickly. I'll write it out. So first of all, we're going to have our x minus 8 times another x minus 8, because we're squaring it, we're multiplying the bracket by itself. That's going to give me x squared for this part, and then it's going to be x times negative 8, which is negative 8x, and then negative 8 here times x, another negative 8x, and then remember, negative 8 times negative 8, that's going to give me positive 64. And again, the same thing applies here. I'm going to have an x squared, because I've got two of these, and these will always be the same when we're squaring a bracket. Negative 8 and another negative 8 is two lots of negative 8, so negative 16x, and then that plus 64. And again, worth noting here as we go through that because we're squaring a bracket, we're always going to get this term here kind of repeated, and this is going to lead us to this negative 16x. So again, looking at this very quickly, because I've got minus 8 there, I'm going to get a minus 8x and a minus 8x, and therefore because this is repeated twice, I'm going to get double that amount down here, negative 16. And again, that last term, this 64 here, is created by squaring this negative 8 here, so negative 8 times negative 8. So a couple of things to note here before we go on. I'm going to take our time looking at this. So I've got our positive 3 here, which means I'm going to have double that, positive 6 before the x. Okay, and negative 8 here, which means I'm going to have double that on the last line, negative 16 in front of the x. And then the last term in both cases, 3 squared is 9, and negative 8 squared is 64. So that means rather than doing all of these steps, I could probably go straight from here to here, and that's what we'll do with the next two. We'll just kind of look at the pattern we've developed here. So let's start off with our x times x. That's going to give me x squared. Then we're going to have x times 2 and 2 times x, which is going to give us two lots of 2x, so positive 4x. And then lastly, positive 2 times another positive 2 in the other bracket is going to give us that positive 4. So we can actually square out the bracket a lot quicker with this in mind. So let's try it again with the other one here. So the x times the x here is going to give me x squared. The x times the negative 5 is going to give me negative 5x, and the negative 5 times the x is going to give me another negative 5x, so it's two lots of negative 5x, negative 10x. And remember, the last term in these come from squaring the number here. So negative 5 times negative 5 is going to give me positive 25. So what's, again, important to note here that'll help us is whatever number I have here, this positive 2, when I square out the bracket, it's going to give me double that amount of x's, okay? And then whatever number I have here, I'm going to square that to get my last term. So again, double negative 5 is negative 10, lots of x's, and negative 5 squared is negative 5 times negative 5, which is positive 25. What we're going to be doing is we're going to be trying to go the other way. We're going to be trying to work our way from something like x squared minus 10x, etc., back to this form. In other words, to put it in this kind of square form here. Now, what's really important with all these, obviously the 4 examples I gave at the very start, this x plus 3 all squared, x minus 8 all squared, x plus 2 all squared, etc., they're all clearly squares because they were a bracket squared. What you've got to understand about this, though, is that the bit at the bottom here is also a square. These things are equal to each other. They're exactly the same. They're just written out in a different form or a different appearance. So if that's a square, this is also a square. If x plus 2 all squared is a square, then x squared plus 4x plus 4 is the same thing. It's also a square. So let's have a look now at how to do this. So we want to take something which is in this form here, and we want to put it into this form here. Now, to start off with, what I'm going to do is I'm going to look at these first two terms, x squared plus 6x, and I'm going to just quickly put brackets around those. And at the moment, what's inside that bracket is not a square. But I could actually add something else in that bracket to turn this into a square. So let's have a look at how we do that. So I'm going to write what's in the bracket there, x squared plus 6x is part of, and you'll remember in the last slide we said, well, if I've got this x squared plus 6x in my expansion, then it must have come from x plus 3 all squared. So as we looked at in the last slide, we took things like this and we were putting it into the kind of expanded form. So this number here will always be half of this number here. So if this is positive 6 lots of x, then I'm going to half that to get positive 3 there. Now, just to remind you, what we did in the last slide was we expanded that. So x times x is x squared. We're going to have an x times a 3 and a 3 times an x. So that's 2 lots of 3x, which is 6x. And we're going to have this positive 3 times another positive 3, which is going to give us positive 9. Now, what we're looking at here is, in this bracket at the moment, this is not a square. Both of these are squares. This is obviously a square, it's got the bracket squared, but because these two terms are equal to each other, it means this must be a square as well. So for me to change that bracket so that it's a square, the easiest way for me to do that is to put this extra 9 in, and then I'll have a square in the bracket. So I'm going to do that just now, and this is what I mean by completing the square. So x squared plus 6x is not a square, but when I add that 9 in, I have completed the square. In other words, I've turned it into this, which I know is a square because it came from this square here. So the other thing is, outside this bracket here, I have this positive 15. So I'm going to leave a little space and I'm going to write that here. Now these lines at the moment, I've put equals, but these two lines are not currently equal to each other because I've added this extra 9 in. Now to compensate for that, I'm going to need to get rid of it again straight away. So outside the bracket, I'm going to put minus 9. Now, what's in the bracket is this square here, which we know is equal to that. So we're going to write that again. So that's x plus 3 all squared. That's the bracket converted back. And then outside the bracket, negative 9 plus 15 is positive 6. So we're just going to simplify that. And now we have it in the form we're looking for. In other words, this form here. We've got x plus a number plus all squared plus another number. So x plus 3 all squared plus 6. We're going to follow that same process again to try this next one. So the first step, remember, is to just put brackets around the first two terms and write our little sentence. So x squared minus 4x is part of, now we know it's going to be x in the bracket. Now have a think about this. This negative 4x would have come from a negative 2x and another negative 2x. So negative 2 is going to have to go in here, and that's all squared. Now quickly square this out. We know that's x squared minus 4x. We already know that's the first two terms because that's where we got it from. And then the last term will come from the negative 2 times another negative 2, which is going to give us positive 4. Now again, what's inside this bracket is not a square, but this down at the bottom here is a square. It's basically this square here, just written in a different form. So for me to complete the square, I need to put something else in this bracket. Now, x squared minus 4x is already there. I need to basically put this extra 4 here into there to complete it, to make it a square, so plus 4. Now because I put that extra plus 4 in the bracket, the lines won't be equal unless I get rid of it again, so take away 4 outside the bracket, and then the plus 5 that was already there. So the bit inside the bracket now is now a completed square. It's this square here, which is equal to x minus 2 all squared. So we can rewrite the bracket in that form, x minus 2 all squared, and outside the bracket, negative 4 plus 5 is positive 1. And again, that's the form I'm looking for, x plus or minus a number all squared plus or minus a number. So x plus or minus a number all squared plus or minus a number. Now this last example, example C, is a little bit harder, and it's a little bit harder because it's got an odd number in here. And that's harder just because it's harder to half. So we're going to follow the same process exactly though, and just see where that takes us. So we're going to bracket off the first two terms. We're going to say x squared minus 5x is part of, and then remember we're going to have a bracket with an x in it, and it's going to be squared, and we're going to half this number here. Now half of negative 5, we could write as negative 2.5, and that's fine if you want to do that, but I probably find it easier to work with fractions here. So the easiest way to half negative 5 is just to divide it by 2 by writing it as negative 5 divided by 2, or negative 5 halves. Now when I come to square this out, it's quite easy again. We're just going to use that same process. I'm going to have an x times an x, which is going to give me this x squared. I'm going to have x times negative 5 over 2 and negative 5 over 2 times x. Now that's basically 5 halves plus another 5 halves, which will give us 5 wholes, which will basically be minus 5x. Now, the first two terms in these are always easy because we already know what they are. So we don't even need to really think about that. The only term we need to think about is this last term here, which comes from negative 5 over 2 times another negative 5 over 2. Now, multiplying fractions, you may have forgotten, so let's have a quick look. Negative 5 over 2 times another negative 5 over 2. Remember, fractions, it's top times top, bottom times bottom. So negative 5 times negative 5 is positive 25. And 2 times 2 is 4. So that's going to give me this extra part here, plus 25 over 4. Now, remember, what's in the bracket at the moment is not a square. Okay, so that's what we have here in blue. To make it a square, we need to have this extra part at the end to make it equivalent to this up here, this square. Okay, so for me to complete the square, this bit needs to be added in. So inside my bracket here, I'm going to put in this x squared minus 5x plus 25 over 4. That's me completed the square. And because I've added in that extra 25 over 4, I need to actually just get rid of it again straight away, compensate. And then there was already a plus 3 outside the bracket. Now, this is my completed square, which we had here, and I know that's equivalent to this form up here. So that's the way I'm going to write it, because that's the required form. So x minus 5 over 2 all squared. And then the bit outside, to simplify that, that's a little bit more difficult. So let's take a bit of space and do the working for that down here. We've got negative 25 over 4 plus 3. Now, if I want to add or subtract fractions, I need a common denominator. This currently doesn't have a denominator. I can think about it as 3 over 1, if that makes it easier. So lowest common denominator, ideally I'm going to make both of these into 4s. Okay, so I'm going to have two fractions both in quarters. That's the lowest common multiple of 4 and 1. And I'm leaving that the same, so I'm going to leave that as negative 25 at the top as well. Not changing the bottom, so I'm not going to change the top. And here I'm multiplying the bottom by 4, so multiply the top by 4. So that's going to give me 12. Now that makes sense if you think about it. 12 divided by 4 is the same as the 3 we started with. That's just 12 divided by 4. Now negative 25 plus 12 is negative 13. So it's going to be negative 13 over 4 goes up here. And that's it simplified. And again, that's in completed square form.